So in this video I'm going to show you how we can use our smart join command quickly and easily to create contours and join all these lines together. These lines are all dashed lines, they were vectorized out of a PDF file. Let's just start off by deleting stuff we don't need. All this data is on one single layer as it came out of the vector, so you've got a lot of text or polyline text that gets in the way. These are all polylines, and where they're out in the middle of nowhere it's probably not a problem, but when they're right on the line it can be an issue. And so we have to first of all separate out the data. Now you can do it with or without separating the data. So I'm just going to show you a couple of lines without separating the data just to show you how this smart join function that we just introduced can help you. So I'm going to run smart join. And in here you've got various different methods of joining. I'm going to use the simple join method, which will just put a jump across there, but we have these other methods like keep first, keep second, find the mean position, or keep the shortest, which we'll use in other examples quickly here this morning. In the single mode here, I'm going to join lines together into a single mode, into a single line rather, or you can use multiple, but multiple really needs to have a little cleaner data than this to work with, and I'll show you how we would do that with geometric selection. But if I go in here and pick a source line right here, then when it asks me for target lines, I can just select a number of lines here, and it's using these tolerances. So I change this to 1.2 because the spacing between these lines is about a foot. So I can now pick these lines right here, and I can just rattle my way through this pretty quickly to join up these lines. I can also collect single lines as well. I can also just say go back to a new line, and I can just start joining. And again, I don't need to worry about whether I'm joining at the right end or the wrong end. Our tool here calculates the correct end all the time for you. So this is great. So when you get in amongst data like this, you can just grab selection here, but when you've got text in the way, you can do this and then just find these two lines. Now that one there I did a mistake, so I'm going to undo that and then just pick these two lines. Now you can go in amongst this and pick this, and then I go back into freeform mode here to collect the data. So doing a single mode allows me to work in amongst other data and sort information out really quickly. But if I really wanted to sort this data out first, I would just pick all this data here and run our geometric selection command and allow that to basically pick all the data here in the graphics that I've got highlighted. It highlights it all here. And then I'm going to go in here and say select some pattern objects. I'm just going to pick a few lines that are representative of the dashes, just pick a few more here just to get some range. Define using objects, and what that just did was picked a range of these. Now it's got a set of filters here, which I'm going to turn these off because I don't need these. I'm just going to use a length filter here. So anything that falls into the length of the lines that I created have now been selected, and you can see it's picked all the contours and basically eliminated most of the other data here. So now I'm just going to relayer that and put it onto a new layer. I'm going to create OG-contours, and let's make these contours green and say OK. Put them on a layer group if you want to, and you can also say they're part of original ground if you're doing takeoff. So at this point now we've got a contour layer. I'm just going to double click on that, and then I'm going to turn that layer off so I can see what's left behind. And so now I can see there's a few lines that got left behind, a few little bits and pieces around the edges and these two big lines, and there's some couple of bits over here that I need to pick. So I'm just going to pause active filtering in here and then just say pick that line and that one, and then pick these two contours that I did over here, and then do these little bits along the bottom that I want to pick. So again, very quickly I can separate this data out, picking a few lines along the bottom here. And then there's a few lines across the top that you would do the same for. And then once I've picked all these, again put these on the contours layer, and then do the same thing with these lines at the top here. So very quickly getting this data onto a single layer that I can use to create all the joins, and then I can go into the next mode of joining all the lines together. So let's just do these. I'll just stop at that point. There's a few other bits and pieces, but you get the point here. And so now I'm just going to go to the contours layer and isolate it. So I got all the contours as I want them, and now I can go back to my smart join function. And if I get nice clean data here, you can see I've missed a couple things, but that's good enough here for this purpose. I can say go into multiple mode here, keep the simple join method, and then I can say pick a source line if I want to. I don't need to do that. I can just pick all these lines, put in my tolerances. This time I'm going to say don't jump more than, let's say, 0.25 of a foot laterally, and then I'm going to use this alternate color scheme, and what it's going to show me at the end is which lines were joined and which lines weren't joined, so I can easily go fix those. Use the straightest join basically if you've got a choice, like in this line here. For example, there's a longer distance and a shorter distance. This one is straighter than this one, therefore it will join straight across the gap here rather than go across the diagonal. I want to hit apply, and so now it's basically joining all these lines together, and you can see it's color coding them as it goes. And so at the end of this process, I'll be able to see instantly what was colored red, what was colored blue. So I can close out I don't need to close that actually. So here you can see where it did and didn't join data together. And so these lines are pretty good. There's a couple of joins up here to do. So I go back into single mode, and now I can just say, using the simple join method, turn off this control because now I'm in manual mode, and just join between these lines. Sorry, single mode, go from here to here. Okay, and then just find any others that didn't join, like that one to that one. Oops, didn't start a new line there. Okay, so start a new line. And then just tab out back here, start a new line from here to here, etc. So I get my lines joined very quickly. So that's kind of joining this kind of data. Now let's take a look at one other data set here that I want to do very quickly at the end here. I'm just going to start a new project. And in this case, this is a set of pond data that came out of a PDF file. And this one has all the usual problems with PDF vector data. Let's just grab this, where we can see here we have all this data set up as individual lines. You can see there's lots of chords around the curves, straight sections, they're all segmented. When you zoom right in, you can see that there's jogs between the arcs and the straights where they end. And so we need to fix this up with geometry changes. And we can fix all this up with Smart Join. So I'm just going to show you Smart Join here. Again, this process without this command takes 15 to 20 minutes at least to join together. In here I'm going to use the shortest mode, which basically means move the shortest segment, or keep the shortest segment and move the longer segment. And now I can just pick all these lines right here, set the tolerances that I want to work with. So I'm going to say allow it to move 0.25. And in here I can then say use straightest join, use alternate colors, and apply. And now it's rattling through that data set right there. And all these lines have now been joined and corrected into continuous lines. All those little nudges have all been fixed. And now we've got all but perfect line work to work with. And then the last piece of this is we can run our optimizer on this. So I can run this data set here and go to optimize line strings. It picks all the lines. I can put in my tolerances. Let's say I want to move these by 0.025. And what it's going to do is it's going to curve fit to reduce the number of nodes in the curves, which means that now I've got the model under my control. So if I optimize the horizontal, because these are all 2D lines, and I want to create line strings on that layer, now it's optimizing this data. And so in this case now these pond lines are now perfect. If I close this out further, you can see I've removed all those extra nodes that were in the original line. That's the original, that's the new line here. Oh, that's the new line. And you can see we've made much better line work out of this to work with, and now we can basically use the break line approximation parameters for surfaces, which means now when I build the model it's under my control. It's not based on the PDF data anymore. And now I'm going to get a much better model with less data, and I'm going to be able to work my volumes and things much faster as a result. So those commands working together, geometric selection, smart join, and optimize line strings, together make a fantastic workflow for turning vector PDF data into really pretty good CAD data for modeling and takeoff purposes. Hopefully you like it. Give us a call if you're interested. Thank you.